Good morning and happy Wednesday. So today we're going to look again at another point of why do we figure what quadratic functions look like on a graph. And specifically we're going to look at how the y-intercept of a parabola applies to a real-world application. So now we're going to a softball game and K hit a fly ball. We have our function. It tells the description of the height of the ball in feet at any given time. So since the height of the ball depends on the length of the time since it was hit, our dependent variable is the height because that depends on how long it's been since it's hit. So let x, which is the independent, equal number of seconds. Remember we talked before that time is almost always the independent variable. Y is going to be the height. This is written in function notation, f of x, but when we do our calculations, we're just going to call that our y. So our output will be dependent on the input following this rule. We're going to label our x and y axes. X is the number of seconds, so x is a measure of time, and that is in seconds, units in parentheses. And then, since our y is our height, we'll write that on the side for the y-axis and label that in feet. Okay, done. So, step 1 finished. The a, b, and c from the function a is negative 16, so we know that opens downward. That's our clue. Our b is a positive 64, and our c is 4. We're going to label our axis, or calculate it first, and then we're going to draw our axis of symmetry. So the equation follows the rule x equals negative b over 2 times a, and then I will substitute the values for a and b. My b is 64 and my a is negative 16. So I end up with negative 64 divided by negative 32. Negative divided by negative is positive. 64 divided by 2 is 2. X equals 2 is the equation for the axis of symmetry. I will draw that as a dashed line on my coordinate plane. Okay, so now I've got my axis of symmetry. So I can, when I find one point on one side, I can reflect it to the other side. Now I'm going to find the vertex. The vertex is a point. Its x value comes from the axis of symmetry. Done. I need to find the y, or the output, so I'm going to copy my function and replace the x value with the x. I just realized here I didn't write my x. Put the 2 in for the x. Follow order of operations. So negative 16, 2 squared is 4, plus 64 times 2, plus 4. Y equals, let's see, 40 plus 24, negative 64, plus 128, plus 4. Y equals 64 plus 4. And that makes y equal to 68 when x is equal to 2. So I plot that point. X of 2, that's 65, 68 would be right here. Done. Okay, so I did that. Graph the y-intercept. Okay, so my y-intercept comes from the c value. The c value is 4. So I'm going to graph it, and then it tells me to name the point. Well, remember the y-intercept is always where x is 0. So the point is 0, 4. On the y-axis, above 0, 4 spaces. And then I'm going to reflect that. 1, 2, 1, 2. Okay, now I have 2 points. Done. And then I'm going to calculate one additional point by picking an integer for x near the axis of symmetry. Well, here's my axis of symmetry. I've used 0, I've used 4 for my x, so I can use either 1 or 3. I'm going to take the 1. Traditionally, I go in the direction of the y-axis when I do this, but sometimes it's easier to go to the other side. But let's use 1. So if x equals 1, to find my y, I plug it into the original function, I calculate following order of operations, and then my output or my x value or my y value gives me the other part of my point name. So this gives me y equals, I'm going to do 2 steps here. 64 plus 4 is 68. 68 take away 16 is 72. So another point that I can use is the point 1 comma 72. I go across 1 up to 72, and something's wrong, because that point can't be higher than that point. So let me see, did my mental math foul me up? So I had 68 minus 16. Well, golly, Mrs. Robbins, that won't give me a number bigger than 68. Okay, it should be 52. So here we are. I can reflect that point. That makes more sense. And then I'm going to connect my points as best I can, making a smooth curve that we call a parabola. Okay. Now, what does the y-intercept mean in this story? Well, here's my y-intercept. Let me look at my labels. If x was time and the time was 0, and h is feet, or the height of the ball, that means that k hit the ball 4 feet above the ground. Or when k hit the ball, it was 4 feet above the ground. At the start of the story, the ball was 4 feet above the ground. So let's say it that way. When k hit the ball, it was 4 feet high, or 4 feet above the ground. When k hit the ball, it was 4 feet above the ground. That makes sense, right? When you hit a baseball or a softball, how high off the ground is it? Right, and then we are finished with the first example.